Everyone comes to same number like you. And in this presentation, I'm able to solve a step response of the given closed loop function. I will go from the original problem statement to the final time domain, which will be in Laplace transform. And for each answer or for each step, the speaker is going to take a clear path relation of it. So the core idea is simple. For a new step, the Laplace domain is 1 over S. So basically, we're going to use this unit step to find the transfer function or to find the response. Thinking.
Then your knife, two of the classical control system representation, and I will restate the problem. We are given the closed loop transfer function G of S, and the input is the unit step in the Laplace domain. The unit step is R of S, which equals 1 over S. Our goal is to find the output response C of T by first finding C of S and then taking the inverse Laplace transform. So you can see why.
Now, I compute the output in the Laplace domain. Since C of S equals R of S times G of S, I substitute R of S equals 1 over S. After multiplication, the factor S in the numerator cancels the S from the set input. So the expression becomes C of S equals S squared plus 9S plus 19 over S cubed plus 7S squared plus 14S plus 8. Because G of S already contains a factor of S in the numerator, the step input does not leave an extra 1 over S term.
You know, very telling. So, hot for trigonometric partial functions. So the next step is to factor the denominator. Yeah, the cubic polynomial factors easily as S plus 1, S plus 2, and S plus 3. S plus, yeah. That lets us rewrite C of S as a sum of three simple fractions. A over S plus 1, B over S plus 2, and B over S plus 4. The rest of the rest is becoming the constant A, B, and C. So we are going to this fraction is great plus minus plus 19 over the total meter here. That's the partial fraction. So A corresponds to the full at x equals minus 1, B corresponds to the full at f equals to minus 2, and C corresponds to the full at x equals to minus 3. Situation, and I'll be talking about the finding values for A, B, and C. To find the values for A, B, and C, using the cover-up method. To find the cover-up method, use the cover-up, we'll be substituting values of S into the equation. And therefore, to find A, we substitute, we put S equal to S minus 1 into the equation. And this gives 11 over 3 for A. To find B, we then find S is equal to negative 2 into the equation. And this yields B is equal to negative 2. And then to find C, we put S is equal to minus 4 into the equation, giving us C is equal to 16 minus 36 plus 19 all over negative 3 times negative 2, which also yields minus 1 or 6. So therefore, at the end, we have A being 11 on 3, 5, B being negative 5 on 2, and C being negative 6, negative 1 on 6.
My name is Samantha Michael, a member of Group 9, and I'm here for Speaker 6. After substituting the constants back into the partial fraction form, each term is now easy to convert. We use the standard rule that the inverse Laplace of 1 over S plus A is E to the minus AT. Applying that to them by 10 gives time response of T equals 11 divided by E to the minus T minus 12 over 2 to the minus 2 minus 1 over 6 to the minus 4t. If we want to emphasize casually, we can multiply the whole expression by u of t.
Okay, so I'm speaker 7. Could you add what, Mark? I'm verifying the solution to see if it's correct. First, if you substitute t equals to 0 into the final expression, the coefficient adds up to 1. So the response starts at 1. Second, as t goes to infinity, every exponential term decays to 0. So the final value is 0. This makes sense because the system has 0 steady state gain for a step input due to the factor s in the original numerator. So the answer is mathematically consistent and physically reasonable. Then to conclude, this is the final answer we got. 11 over 3e, which exponents raised upon negative t minus 5 over 2, e raised upon negative 2 minus 1 over 6, e raised upon negative 4 over t, u of t. The unit step response begins at 1 and then it decays through 3 exponential modes and finally settles to 0. Right. Thank you.